Today I'm going to be discussing the difference between a hypervisor and virtual machine manager. Then I'm going to move on to components of virtualization, and then I'm going to have a brief discussion on software-defined networking. I have a whole lot of information to impart, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin with hypervisors and virtual machine managers. So what is the difference between a hypervisor and a virtual machine manager? The difference could be nothing, or the difference could be everything. Some people use the term hypervisor very broadly. They use it to refer to any of the software that is used to manage virtual machines. Others will differentiate between the two terms in this way. A hypervisor does not need a host operating system, while a virtual machine manager, or VMM, requires a host operating system such as Microsoft Windows, Apple OS X, or a Linux operating system, while the hypervisor can operate as its own operating system. With that covered, let's talk about some of the components of virtualization. First up is the virtual desktop. A virtual desktop is a virtual machine, or VM, that functions as a desktop. Now, any modern operating system can be run inside of a VM desktop. Multiple virtual desktops may be hosted on or from a single host system. Then there are virtual servers, which surprisingly is a virtual machine that functions as a server. Any modern server operating system can be used in a virtual server environment. Multiple virtual servers may be hosted on or from a single host. Guess what? There are then virtual switches, firewalls, and routers. These are virtual machines that fulfill the functions of the switch, firewall, and router. Virtual firewalls and routers are particularly effective when they are combined with virtual network interface controllers, or virtual NICs, and virtual switches to create virtual networks. Speaking of virtual networks, an important consideration for when designing a virtual network is how that virtual network is going to pass traffic to remote networks, or networks outside of the host system. Virtualization by its nature leads to either an open and highly scalable network or a closed self-contained system. It is possible to create a completely self-contained network with all of the virtual components and never have network traffic leave the host machine. But if there is a desire or need for that network traffic to pass beyond the host system, then that function needs to be specifically granted. A connection must be created between the host system's physical NIC and the virtual networking equipment to allow network traffic to pass through the physical host system. Next up, software-defined networking. Software-defined networking, or SDN, is the process of allowing the administration and configuration of a network to be done dynamically. With SDN, the administrator uses a front-end program to make adjustments to the network. This program sends the instructions to the networking equipment, which is then reconfigured to perform as the administrator desires. SDN can allow network administrators to dynamically adjust network performance without the need to log into each individual device that needs to be adjusted to achieve the desired performance. SDN is considered to still be an emerging technology, but SDN also works well for virtual networks and cloud computing. Now that concludes this session on virtualization technology. I talked about hypervisors and virtual machine managers. Then I moved on to a brief discussion on some components of virtualization, and I concluded with another brief discussion on software-defined networking.